Right now, something strange is happening in our solar system. A small comet that spent most of its life almost invisible to us suddenly erupted, becoming thousands of times brighter in a matter of hours. And then, just when astronomers thought it was settling down, it erupted again. This is Comet 220P, McNaught. And what makes this story fascinating isn't that the comet is enormous. It isn't. Its solid nucleus may only be a few kilometers across. The mystery is how something so small can suddenly surround itself with a cloud of gas and dust large enough to make it look completely transformed. Comets are often described as dirty snowballs, but that description doesn't really capture what they are. They are ancient leftovers from the formation of the solar system, made from frozen gases, dust, and rocky material that have been traveling around the sun for billions of years. For most of their lives, they are incredibly difficult to notice. Then they approach the sun. As sunlight heats their surfaces, frozen material begins turning directly into gas. That gas escapes from the nucleus, dragging dust with it and creating the enormous glowing cloud we call a coma. Sometimes, however, something much more violent happens. A crack can open on the surface. A section of crust can collapse. Buried gases can suddenly escape. And when that happens, a comet can brighten dramatically almost overnight. That appears to be what happened with 220P, McNaught. The comet was discovered in 2004 by Australian astronomer Robert McNaught. At the time, it was extremely faint, requiring a powerful telescope to detect. It belongs to a group known as Jupiter family comets. These are comets whose orbits have been strongly influenced by Jupiter's gravity. Instead of taking thousands or millions of years to return, many of them circle the Sun in only a few years. 220P, McNaught takes roughly 5.5 years to complete an orbit. For years, it behaved much like astronomers expected. It approached the Sun, became brighter, moved back outward, and faded again. Nothing about it suggested that it was about to become a major astronomical event. Then came 2026. Astronomers monitoring the sky noticed that something had changed. The comet suddenly became dramatically brighter. Its brightness increased by several magnitudes in a remarkably short period of time. To understand just how extreme that is, astronomical brightness is measured on a logarithmic scale. A change of only a few magnitudes can represent a huge difference in actual brightness. This wasn't simply the comet becoming gradually brighter as it approached the Sun. It was an outburst. A sudden release of material from the nucleus. Imagine a frozen mountain traveling through space for billions of years. Underneath its surface are layers of ice containing volatile compounds such as carbon monoxide and carbon dioxide. As the comet gets closer to the Sun, those materials absorb heat. Pressure builds. Eventually, a weak region of the surface can fracture. Gas escapes. Dust is thrown outward. And suddenly, sunlight has an enormous new cloud of particles to illuminate. The comet hasn't suddenly become a giant object. The cloud around it has. That distinction is extremely important. The nucleus remains relatively small, but its coma can expand to hundreds of thousands or even millions of kilometers. And that is why a comet can sometimes appear far larger than the solid body that created it. But 220P, McNaught didn't stop after its first dramatic outburst. Astronomers continued watching it. The comet gradually faded. Its activity appeared to be decreasing. Then another surprise arrived. A second major brightening was observed. For a comet to produce repeated major outbursts during the same passage around the Sun is much more unusual. And now scientists have a much more interesting question. What exactly is happening beneath the surface? One possibility is that the first outburst fractured the nucleus and exposed fresh material. That newly exposed ice could then receive direct sunlight and become highly active. Another possibility is that the nucleus is structurally weak, with different sections held together relatively loosely. If that is the case, one eruption could destabilize another part of the surface, leading to a second event later. There is also a possibility that the comet simply contains pockets of volatile material at different depths. As different regions heat up, different pockets could suddenly become active. The important thing is that scientists cannot simply look at a comet and know exactly what is happening inside it. We can observe the light. We can analyze the gases. We can measure its motion. But the nucleus itself remains a tiny, distant object surrounded by a constantly changing cloud of material. And that cloud contains clues. During observations of the comet, astronomers detected carbon molecules, including diatomic carbon, commonly written as C2. This is particularly interesting because C2 contributes to the green appearance seen in many comet images. When sunlight interacts with these molecules, they can emit light at specific wavelengths. That produces the characteristic greenish glow that astrophotographers sometimes capture around a comet's head. So when you see a photograph of a green comet, you're not simply looking at a camera effect. You're seeing chemistry. You're seeing molecules responding to sunlight millions of kilometers away. And that chemistry has a story to tell. Comets are essentially time capsules from the beginning of the solar system. More than 4.5 billion years ago, the planets were forming from a huge disk of gas and dust surrounding the young sun. In the colder outer regions, water and other compounds could freeze. Some of that material never became part of a planet. Instead, it remained trapped inside small bodies. Those bodies became comets. And they have been carrying that ancient material ever since. Every time a comet approaches the sun, some of that material is released into space. That means astronomers can study gases and dust that preserve information about conditions that existed when the solar system was still young. In a sense, a comet is a piece of ancient history that occasionally opens itself and lets us look inside. But 220p, McNaught is also teaching us something else. Comets are unpredictable. We understand the basic physics extremely well. We know sunlight heats the surface. We know volatile materials can turn into gas. We know dust can be released. We know the solar wind can shape the tail. But predicting exactly when a comet will suddenly erupt is much harder. And history has shown just how dramatic these events can become. In 2007, Comet 17P, Holmes experienced one of the most spectacular cometary outbursts ever recorded. It suddenly became millions of times brighter. The cloud surrounding its nucleus expanded to an enormous size, eventually becoming larger in diameter than the Sun. And yet the solid nucleus responsible for that enormous cloud was only a few kilometers across. That example shows why astronomers don't judge a comet's apparent size by the glowing cloud surrounding it. The nucleus can be tiny. The coma can be enormous. And the tail can stretch millions of kilometers through space. For 220p, McNaught, the recent outbursts have produced exactly the kind of behavior that keeps comet observers watching night after night. Because the next question is simple. Is it finished? Nobody knows for certain. The comet could continue fading as it moves away from the sun. Or another region of its surface could suddenly become active. Another crack could open. Another pocket of gas could escape. And the comet could brighten again. That uncertainty is one of the reasons amateur astronomers are so important. Professional observatories cannot watch every comet every minute of every night. But thousands of observers around the world can photograph the sky, estimate brightness, compare images, and report changes. A comet can suddenly become active, and within hours, observers across the planet can begin documenting what happened. That creates something remarkable. A global scientific network made up not only of major observatories, but also of people pointing telescopes and cameras at the sky from their own backyards. And there is no reason to be afraid of 220p, McNaught. Despite the dramatic appearance of its outburst, the comet is not on a known collision course with Earth. Its current orbit keeps it far from our planet. What we're witnessing is a spectacular astronomical event occurring at a safe distance. A small frozen body is responding to sunlight in a way that allows us to watch ancient material being released into space. And that's what makes this story so much more interesting than simply saying, a comet got brighter. Because when you look at a comet, you're looking at something that may have existed before Earth itself.